Hi everyone, my name is Mann Shah and today I'll be presenting a very influential research paper titled as Elections in a Distributed Computing System by Hector Garcia and Molina, published back in 1982. So this paper introduced one of the earliest and most famous algorithms in distributed computing, that is the Bully algorithm, and later a second one known as the invitation algorithm. So these algorithms help computers in a network to decide who should be the leader or so-called coordinator when something goes wrong, like when a server crashes or communication fails kind of scenarios. Okay, so in this presentation, I'll go over four main things. That is, first of all, what problem this paper solves and why it matters. Secondly, we'll take a look at the two algorithms, that is the bully and the invitation algorithm, and we'll take a look at how those algorithms actually work. Then we'll go through why this paper is so important in computer science. And finally, we'll go through my personal opinion on the research and how it is still relevant today. So let's start with the problem the author was trying to solve. Okay, so in a distributed system, that is a group of computers working together, each machine can fail or crash at any time, right? Now, when this happens, the system still needs one machine to act as a leader or so-called a coordinator to manage this system and bring it back to the normal stage, right? Now, the big question is when the leader fails, how do the other computers automatically agree on a new leader without any human help? Now, this is what we call the leader election problem, and this paper proposes two clever solutions to solve it. Now, the key idea of the paper is that every system should have one node that takes the charge, that is the coordinator. Now, if that node, that is the coordinator node, fails, the others must elect a new one through a set of rules. Now, Garcia Molina doesn't just give the code, they define what a correct election means using assertions, basically rules that say all computers must agree on the same leader, then the process must always finish and should not be stuck forever. Then they propose two algorithms to achieve this, that is the Bully algorithm and the invitation algorithm. Okay, so to keep the things structured, the paper first assumes an ideal environment, that is, no message loss, no delays, everything works perfectly. Then it relaxes that assumptions and says that, okay, what if some messages are lost or part of the network is not able to talk to each other, right? So we get two models here. That is, first is the perfect communication that represents Bully algorithm, and the second is possible communication failures, that is the invitation algorithm. So this step-by-step approach makes the paper easier to understand and applicable to both simple as well as complex systems. Now, Garcia Molina used three main rules which they called assertions. Now, first of all is the consistency. So, every active node must agree on the same coordinator. The second one is liveness. Now, if no new failures happen, eventually one leader has to be chosen. The third one is partition awareness. Like if the network splits into groups, each group should have its own local leader until they reconnect. So these are like the rules in an election. There must be one clear winner and the election should eventually end. End, of course. Now let's dive into the Bully algorithm, the most famous part of the paper. Now here's how it works. When a node realizes that the coordinator is down, it sends an election message to all the nodes with higher IDs. Now if anyone responds, it knows there is someone stronger alive, so it waits for it. If no one responds, that node declares itself as the new coordinator. Finally, it sends a message to everyone saying like, hey, I'm the new leader. This algorithm is known as the Bully algorithm because the node with the highest ID bullies everyone else into accepting it as the leader. So now let's take a real world analogy to understand bully algorithm. So imagine a classroom with students numbered from 1 through 5. The student with number 5 is the class captain. If the student 5 leaves the room, student number 3 notices and asks the students 4 and 5 if they are around. And eventually nobody responds. So student 3 stands up and says like, okay, I'm the new captain then. So that's exactly how the bully algorithm works. The one with the highest rank still standing becomes the leader. It's fast, simple, and easy to implement, which is why it became very popular. Now, but what if the network isn't perfect? Like maybe the messages are lost or some computers can't talk to each other because of a network issue, let's say. So that's where the invitation algorithm comes in. So in this case, every node starts as its own tiny group and calls itself a leader. Now, then coordinators invite other groups to join them. Now, these individual groups, gradually merge until one leader is remaining. So, this algorithm is slower but more realistic. Like, it works even when parts of the system can't communicate with each other. So, think it of like what happens when a company's CEO resigns. So each department head temporarily becomes the leader of their own department. So after a while, the heads start talking like, hey, maybe let's merge finance and HR, or let's merge sales and marketing. And eventually they all agree on one new CEO to lead the entire company, right? So that's how the invitation algorithm works, through cooperation, like instead of bullying each other. So Garcia and Molina's paper is one of the most cited works in distributed computing, thousands of citations even today. So the bully algorithm is still taught in universities and appears in textbooks like Distributed Systems by Tenenbaum. Its concepts influence many modern systems, for example, Paxos, Raft, and Zookeeper, which are currently being used by Google, Netflix, and many other big tech companies to maintain consistency in large scale systems. So, even though the algorithm is like 40 years old, its ideas are still running behind the scenes in systems that we use in our day to day lives. So personally, I find this paper extremely elegant. Like the bully algorithm is simple, easy to understand, and perfect for stable networks. But it has one big drawback, I believe. Like it creates a lots of messages when there are many nodes, and it assumes perfect communication. The invitation algorithm, on the other hand, handles real-world conditions like partitions, but it's a bit more complex and slower, I believe. So while going through the paper, few questions came into my mind like, can we make elections faster and use fewer messages if possible? Then how do we handle elections in an asynchronous network, like where the delays are unpredictable? Then can the leaders rotate fairly, like instead of always choosing the strongest node? And finally, can we use AI based systems like that can automatically pick the most reliable leader based on the performance metrics? So these are some of the questions that I had. To summarize, the paper solves the leader election problem in distributed systems. It presents two algorithms, namely the bully and the invitation algorithm. The paper defined clear correctness rules that became the foundation of many later systems. Even after 4 decades, this research remains highly relevant to modern distributed systems like databases, Kubernetes, and cloud services that are working today, right? Thank you so much, everyone, for listening. I hope this presentation helped you to get a good clarity about what Bully algorithm and invitation algorithms are and how such kind of research can shape the future of distributed systems. I'm happy to take any questions now. Thank you.